Good afternoon, everyone. My name is Damián Gómez. I'm from Argentina. I've been working at Immunity for almost 2 years. As a security researcher, I focus on vulnerability analysis and exploit development. I'm the leader project of the Visual Exploit framework, and among my current projects, I'm the main developer of Immunity Debugger, which is the subject of this talk. Well, anyone who has ever coded an exploit will tell you that 90% of their development time was spent inside a debugger. Like with all the software engineering that exists today, the actual language implementation is somewhat irrelevant. Let's say as soon as you can craft a string, it's more likely you're going to be able to code an exploit. Immunity last year introduced a graphical language for exploit development called Visual Exploit, which was based in the concept of drag and dropping exploit components from a toolbar to a panel and having as a result a readable exploit. So you can see the programming language is not something that will matter at the end, since an exploit is merely a solution to a problem that was solved using your debugger of choice. A problem that requires intelligent understanding of concepts like input crafting, of heap analysis, memory manipulation. It's okay. Let's say inside a debugger you should be able to get the first abstract approach of your bug and the last concrete goal, the shellcode execution. So, what do we want from a debugger? For a vulnerability development debugging framework, we want a simple, understandable interface, and we want to be able to script things, so we want a powerful scripting language in it, and we want it to be fast. Unfortunately, there is no perfect interface model for every exploit development situations. But there are some characteristics that will help us achieve what we want, and those are a GUI, a command line, and that scripting language. So why a GUI? The graphical interface will make us a favor, like it will be easy to have a visualization of the CPU context or the stack. Let's say it's easy to see where EAX points or any register, and a graphical interface is faster to learn for complex commands. You just don't have to learn the complex commands, but you click them. But it has a downside, and it's the slower usage than the command line. And that's why we love the command line. The command line is a faster way to interact with the debugger. But let's say there are some complex commands that will be hard to remember. At least you are a full-time debugger user. So you have to be checking the manual every time you want to type these complex commands. And we don't like this. And the last thing we are looking in this kind of debugger is the scripting language. But forget about those old awkward scripting language for debugging. We want a real scripting language. And Immunity Debugger has Python like the scripting language. Python is familiar and easy to learn. I mean, it's really easy. So these characteristics will, at Immunity, with Immunity Debugger integrates these 3 characteristics in his own vulnerability development exploit-oriented debugger. We have been using Immunity Debugger for some time at Immunity, and we have great results during our testing. There is a screenshot of Immunity Debugger session, which you can see there is a Python command at the command bar dumping the heap in a custom log window right in the upper side of the screenshot. The Immunity Debugger API. The Immunity Debugger API is simple. I mean, it runs like a cached structures of to speed up the experience. That means it's pretty useful, for example, for searching functions when you're doing some memory deep searches. It's good to have some cache of them. And the Immunity Debugger API, it can not only perform debugging tasks, but it can also interact with the current GUI. Like, you will have all the debugging tasks, like step in execution, assembly, but also you'll be able to control the GUI. And there is something extra to say, that is, keep in mind that when you are running a Py command, the information will generate runtime, so every script run is ephemeral. But how deep can we dive with the API? Well, we can do mostly everything. For example, we can do assembly and disassembly methods, breakpoints, reading and writing in memory, searching, execution, and stepping and analysis with it. And as I said before, interacting with the GUI. What offers that to us? Well, creating new custom windows for displaying your data, or tables, dialog boxes, input boxes, combo boxes. There is a script, find anti-DIP script, that has a wizard that will guide you through the execution of the script. But the best way to show how interaction with the GUI is possible is with the Python orthogonal grapher. The Python grapher is a graphic library that will make a graph of the function, an orthogonal representation of it, and is entirely coded with the Immunity Debugger API. Well, among Immunity Debugger methods, we can read and write into memory. Like when you're calling an exploit, it's more likely you are going to be manipulating memory all the time. So there are a lot of methods for reading and writing memory. And something else you will be doing while developing an exploit is searching for patterns in memory. So the Immunity Debugger API has a lot of searching methods, like the simple search, which will search in memory, or, for example, searching commands. Commands are searching commands which you can, for example, search regular expressions with it. And if you want a deeper search, you can even use the assemble method. You can assemble a command and then search it in memory. Okay, getting code cross-reference from data and code. It's also possible from the Immunity Debugger libraries. And this is the Immunity Debugger knowledge. As I said before, when you run a script inside Immunity Debugger, that script is run and logged in there. So there is a way to save into Immunity Debugger memory the information of that script. The acknowledge method will do it. Like, for example, you can save the CPU context inside a Python object and save it into the Immunity Debugger session with the acknowledge. So you can get that CPU context later with the acknowledge methods. There are three ways to script Immunity Debugger: the Py commands, the Py hooks, and Py scripts. I'm going to talk about the first two ones in this talk. The Py commands are Python scripts. It will help you decreasing the development time. These scripts are no caching, so that means you can run modifying a script and rerun it without the need to restart the debugger, so that's pretty useful. The Python commands are accessible via a command box or from the GUI. and you can integrate the Python commands to the debugger features. Writing a Python command is easy. You just have to create a file, import the library, and define a main function where you can instantiate the API and start using it. Then you just place that file into the PyCommands directory and you're ready to go. And PyHooks. Hooks are objects that hangs on debugger's events like access violation or any breakpoint or post-analysis hooks, etc. The good thing of hooking is that you can hook that event and place in Immunity Debugger session memory some code that will be executed when that event happens. So you can create a hook on an access violation to save the CPU context at this right moment and will be executed when the access violation happens. Creating a hook is easy also. It's almost like creating a Python command with a difference that you have to define a run function that is the one that will be executed when the hook type happens. This run function will receive the CPU context as argument just to avoid three problems. Since hook is very related to threads. There is some easy way to identify a common vulnerability primitive with hooking. Let's see an example. For example, this string and copy, where the size argument is the same as the exact size of the source argument. Just with minor modifications of this script, you can find primitives in other functions. So let's see this example of hook. First of all, we start instantiating the debugger class, and we're setting a breakpoint in the string and copy function. Then we're creating our hook and adding to the Immunity Debugger memory. And inside our class or hook class, we define run, where we instantiate the lib, and based on the CPU content we receive it, we are going to read the arguments that are passed to the string and copy function. Once we have all the arguments, we're going to ask if the length of the read argument is the same as the size argument. In that case, we are going to get the call stack and log it. There's a screenshot of that script running. Check how the call stack is logged at the source when the source argument is the same length as the size argument. There is another type of hooking, which is inject hooking. The inject hookings are a logging hook. They are much faster since it doesn't use the debugger. You can inject code, assembly code directly in the function, and it's redirected to your code. The information is logged in the same memory page, so it's pretty much faster. The heap analysis tool uses the feature. However, injection hooking has some drawbacks. Since now you can only report the results and cannot do conditional with it. In this example, we are creating this inject hooking, and we are using the acknowledge method to save the information into Immunity Debugger memory. And later, with another script, we are using the getKnowledge method to get that fast hooking and logging the result we have while debugging. There is another thing included in the Immunity Debugger, and are the heap libs. Since heap analysis is one of the most important tasks for exploit development, we have included a set of libs to help for that. These libs allow us to print the state of memory, or examining the heap, or saving or storing the heap. For example, we can get all the current heaps, or we can get a single object heap, since when you are doing some exploit development, you may want to focus just in one single heap, where you can get from this single heap the free list or the free list in use. And in the same way, you can get the chunks of every heap or from a single heap object. And again, these chunks are objects itself, which has a lot of information in it. Easy to access information. You can search inside chunks, like, okay, you can search inside chunks, and you can specify, if you want, like an optional heap argument to filter by heap the search. There is another libraries, the data type discovery libraries, which help you finding types of data in memory. That's pretty useful when coding an exploit, to know where and what is in memory. For example, you can go and do a discovery of memory of a pointer, and that will return an object, and you can ask in that object if it's a function pointer or a normal pointer, a data pointer, a stack pointer, and so on. Or there is a simple, well, this slide should talk by itself. We have Take Heavy trying to use PyCommands and PyHooks, which use the Python API to analyze, fuse, search, discover, and most important, understand what is going on inside the debugger to create an exploit. During the past month, Unity team has been coding some script that was helping us while developing exploits. These scripts include vulnerability analysis heaps, protocol searching, finding, and comparing memory. There are some examples of the scripts created. For example, SafeC that we show you in a custom window. All the exception handlers in a process that are registered with SafeC. The find anti-DIP script, which will find an address to bypass software DIP. This script was used in one of Unity training, and that's why it has a wizard on it, where the first combo box asks for the first address, then you have an input box for inserting the assembly code to search, and lastly, you have another combo box that will search for the third return address. And you can see the lower screen that shows a buffer that will help you bypass the IP. There is another script that will find memory leaks in a function. It's a hook. It will hook a function. Then you will be fuzzing that function, and you will be getting the leaks. Check the red line where a mem leak is detected in that function which was hooked by leg sniff. Finding data types in memory is another script that will help discover what kind of data is inside the memory. You just have to specify an address and the size to read, and in the log window will appear what kind of data the discovery list found. And the heap by command. With the heap by command, you can make analysis of the heap and dump it and check what's inside, like the screenshot shows. For example, check the double linked list that the heap by command found. There is another script, the chunk analyze, that is another hook where you specify the address of the drive move, and you run the hack. You place it into memory, and you start fuzzing. If you check the log window, you will be able, what of your fuzzing is overwriting a function pointer of a double linked list. or the get RPC. The get RPC will access to RPC information and will give function pointers of every RPC call. The duality script. The duality script will look at memory pages and others that can be transformed into opcodes. This duality script will be described more later in the talk in the case study I have prepared. The mod pointer script. This tool will do some data recognition looking for function pointers, and it will override them, waiting for an access violation of one of these pointers overwriting, and when the access violation occurs, it will trigger the hook and will start logging in for further analysis. And the search script. The search script is a simple script that will search for cryptographic routines in a given branch. Look at the screenshot how a lot of different algorithm was found in a library. And we have a case of study here. It's a simple stack overflow in Savant web server. When you send a long GET request to it, it would crash with a stack overflow. However, there are some details on it. For example, when you send a long buffer, the some stack arguments overwriting won't allow us to reach EIP. Check the screenshot. The lines is showing how an argument, a readable address, is overwriting and getting an access violation when reading this address. So we need to find a readable address to place as the argument there in the right offset. Once we find this, which is pretty easy, we'll be facing the second argument problem, a readable address. That's almost as easy as the first one. We just need to find a readable address. So, repeating, to keep EIP, we need a readable address, that readable address, and the argument offset in our screen thing. Finding the offset should be easy, so when we got that addresses and the offset, we can craft a buffer that if the address we found are right, we'll be able to hit EIP like the screenshot shows without any problem. So once we hit EIP, in detail we have control over EVP value, AP value, what ESP points to, which is one of the arguments, and what ESP plus 4 points to, which is the other arguments. And we have more of 200 bytes of a controlled buffer. There is the context I was talking right here. And the first thing I could think of with this context is jumping back. But how? And that's the second problem. Check where what ESP is pointing to. Since we are controlling what ESP points to, what if we could find an address to place as the overwriting argument, which first of all needs to be writable because of the first problem, and second, it can be transformed into opcodes that would be of use here, like let's say a jump back to land into our control buffer. But finding an address with these characteristics might be pretty tedious and pretty hard. So there is a script with Immunity Debugger that we talked some minutes ago that would help here, the duality script. The duality script is easy to use. You just have to place the command as argument to the script you are looking for. And how duality works? Well, it creates a mask of the searched code, in this case a jump -10, and we'll get all the memory pages and we'll try to find addresses that match our masked search codes. As we can see in the screenshot, the log results, there is an address marked with a red line that may be of use here. So, before finishing crafting our string with a brand new address, transformable address, we'll need to find a jump ESP for AIP. The search code script will do that really fast. You just have to write search code and the command you are willing to search. So, resuming, we have bypassed the arguments problem, we have hit EIP, we have searched for a writable address that can be transformed into an opcode, and we have searched for a jump ESP, and we have crafted the string. So, if everything goes well, we'll be having our int3. Check the right red box where ESP is, which is pointing to an address that in the disassembly window is transformed to a short jump back to land into our controlled buffer. Okay. Yes. Now I'm going to do some Immunity Debugger demo. Hard to check. Okay, now Immunity Debugger demo. Okay, let's go for the conclusion then. So, Immunity Debugger won't give you an out-of-the-box exploit, but it will speed up the time debugging because of the GUI, the graphical interface, and the command line, and it will help you finding the bug with the API and the libraries and the immunity scripts that are provided with Immunity Debugger, and will help you crafting your exploit, making it more reliable. We have been using Immunity Debugger for months while build dev with good results. And some things that are inside my head right now is an API server to connect the Immunity Debugger to Visual Exploit, Canvas, or Fossers, or whichever application that could be of use when doing some vulnerability development. More graphing stuff like interaction with the graph, so we can manage vertices and move them around, and even clicking in them to modify the assembly and so on. And also a lot of py commands that comes every day. When we need it, we code them. And your script, yeah, that's something I was thinking about also. Immunity Debugger is pretty curious about what you can do with Immunity Debugger API. So we have launched a little contest for the most useful script, where the first prize will be a Silica unit. I think it's up to October 10th or something like that. So if you're willing to code some script of use, just drop me a line later. You can download Immunity Debugger, get it free, and comments, scripts, idea, and request, please email me. I'm willing to answer any questions you might have, but I think that's in the question and answer room. So that's it. Okay.